So degeneration of the substantia nigra, remember, which is a brainstem nucleus that is a dopaminergic nucleus that sends its dopaminergic projections, its axon terminals out to synapse and release dopamine with neurons that are found in the gray matter of the basal ganglia, specifically components of the basal ganglia that are called the striatum, right? It includes parts of the caudate and the putamen. These dopaminergic projections are actually critically important for movement and the timing of movement and the initiation and the stopping of movement. If there's degeneration of this, what we call nigro, because it's starting from the substantia nigra, striatal, because it's connecting, and releasing dopamine in components of the striatum, of the basal ganglia. If the substantia nigra degenerates, we can have significant loss of movement function. And this is a disorder that's called Parkinson's disease. And what's fascinating, I think, about Parkinson's is how you need to actually lose about maybe 70% or so of the neurons, of the dopaminergic neurons, of these projection neurons that form that nigrostriatal pathway, before people tend to actually report symptoms of Parkinson's disease to, let's say, a neurologist. And what's interesting is if you look and ask folks retrospectively what they were experiencing, they actually initially often ascribe the significant slowing, that they're engaged in. They actually, symptoms in Parkinson's disease include what's called bradykinesia, like a slowing of movement, akinesia. A means no movement. They can get frozen, in advanced Parkinson's, and also often the first symptom is sort of like this resting tremor. You try to hold your hand steady and it'll tremor like this. But they often, when asked, like they say, like 6 months ago, it just seemed like everybody around me was running around like rabbits. Like, people were moving so much faster, and I was maintaining, like sort of a normal pace, and so it's actually quite interesting. The basal ganglia and these dopaminergic projections not only have impact on the timing of our own movements, but it's also potentially a little bit on the perception of time and how fast things are going and how quickly people are sort of moving around us. And so this is obviously like a significant illness, and it's degenerative. So typically, once people have the symptoms, they're going to get worse as more of these dopaminergic neurons in the substantia nigra die off. And there's a lot of interest in what causes Parkinson's. And there's some evidence for perhaps some environmental influences, like the rates of Parkinson's disease, for example, are higher amongst migrant farm workers who may be exposed to more significant kind of agricultural chemicals that could be doing damage. There's a infamous sort of incident where in Palo Alto or Menlo Park in Northern California, where there were some young people who were trying to manufacture drugs, and they generated as a byproduct this chemical called MPTP, and this actually looks a lot like dopamine, but it's sort of a free radical, so it can very rapidly react with other chemicals, basically, and it got selectively pulled into dopaminergic neurons in the substantia nigra, and then it damaged the mitochondria and killed off those cells. So these were actually 18-year-olds, 19-year-olds who had, were akinetic. They couldn't move. They had slowness of movement. They had full-blown Parkinson's disease at a very young age. And this actually was the spur for the development of a huge Parkinson's center, actually at Stanford University down in Northern California. But Parkinson's disease, is treated initially, typically with drugs, and you can't give dopamine because dopamine, won't cross the blood-brain barrier. But what's often what was the first sort of major drug that was very effective is something called L-Dopa, which, remember, is part of that synthesis pathway for the neurotransmitter dopamine. Remember, tyrosine, which is the raw material, the amino acid that is, basically going to be converted ultimately into dopamine. We're going to see also into norepinephrine, the catecholamines, is grabbed onto by the first synthesizing enzyme, and then it's converted into this intermediate chemical product called L-Dopa. And so by adding in L-Dopa, by generating more, which would cross the blood-brain barrier, you would actually be selectively taken up into these dopaminergic cells, and then it would increase the synthesis, of dopamine. There'd be more dopamine for release at the remaining dopaminergic projections, from the substantia nigra into the striatum. So this was a remarkably effective treatment, and it still remains, pretty much an early treatment for Parkinson's. It's not a great long-term solution because what you're doing, of course, right, is you're enhancing the signal, out of the remaining, dopaminergic cells. So you're increasing the amount of stimulation of all those postsynaptic metabotropic the dopamine receptors at the remaining synapses, right? You're enhancing that signal. And so you're overstimulating metabotropic receptors. So you're going to generate more G protein, more second messenger, more activity along biochemical cascades, right? Depends on the receptors that you're stimulating. But that often results, right, in a downregulation, of receptor expression. So people tend to have to keep increasing the dose, right? They're developing tolerance to the effects of L-Dopa as a drug to treat their Parkinson's symptoms. And ultimately, it throws off other circuits, other downstream circuits in the basal ganglia. So people can have other movement disorders that can start to result, something called tardive dyskinesia, et cetera. So it's not the best long-term solution. However, it's usually the front line because it's less invasive than what they are now doing quite a bit. And OHSU, has a huge Parkinson's program. They are often trying to basically descend electrodes, directly into, the nigrostriatal pathway to do what they call deep brain stimulation, to, replace that stimulation, that was dopaminergic, with direct electrical stimulation. And that's been actually rather remarkably effective. So the nigrostriatal pathway is critically involved in movement. And L-Dopa is typically the first, kind of drug treatment. Ultimately, people sometimes have to, move to deep brain stimulation. The other thing about L-Dopa as a treatment, or these, drugs that are used to treat Parkinson's, is that they're not very specific for the nigrostriatal pathway, right? Because there's also the mesolimbic and the mesocortical pathways that are involved in sort of the salience and the motivational value, stimuli in your environment, like would drive you to respond. And so you not only get enhanced dopamine release, in the nigrostriatal pathway, which helps to relieve the movement symptoms of Parkinson's, but you may also get enhanced dopamine release in the mesolimbic and mesocortical pathways, which are involved in your motivated responses to stimuli that predict the delivery of reward. So there's a black box warning now on these drugs for Parkinson's about don't go to the casino, right? Because you're surrounded by stimuli that predict the potential delivery of reward if you do this. If you put your money in here and you do put your money in there. So it's actually it's a spur to greater risk taking, with potential reward. And it can have, devastating consequences if people lose all their money, for example, at a casino. So dopamine is a fascinating neurotransmitter and involved in, both movement and in motivation.